Hey everybody, we're going to pick up with equations, and we're going to be camped out on equations pretty much the whole week. And this is one of those skills that doesn't go away in algebra, and you're going to need to know how to solve equations very much so when we do other things. So first, just a little bit about the difference between solving an equation and simplifying. So last week we simplified expressions. Expressions can only be simplified because they don't have an equal sign. So we can't find what the value of the variable is. And they were things perhaps like this. That was an expression. And so to simplify the expression, we did distributive property. So 2 times x and 2 times 5. And then notice the 3x and the 7. That didn't change in that step. And then now combine like terms. So, ooh, hello. Not what I was looking for there. The 5x plus 17. And then that was as far as we could go. It was an expression. It was not an equation. But an equation has an equal sign in it. An equation consists of equal expressions joined by an equal sign, and an equation is solved, like the directions might say solve or find the value of x. So an equation could be something like 3x plus 2 is equal to x minus 6. So both sides are expressions and they're set equal to each other. And then our goal would be to find out what value of x would make this true. And we won't do an equation quite like this one today. But just to give you an idea, both sides are expressions. One side could be as simple as just a number though, so it could be much simpler. So an equation is a math sentence, and the verb is basically the equal. This stuff equal this stuff, those expressions. And the solution is the value that makes the sentence true. That's the answer we get when we solve. It's called the solution. So I'm going to show you in IXL so that you can visualize what equations kind of mean before we actually talk about how to solve them. And if you already know how to solve them, bear with me, I promise I'll get there. So this is J1 in IXL. And oftentimes, pre-COVID, in class, I might give you each a set of algebra tiles, some very tactile, physical things that you could work with. In fact, I may have some sets of foam ones. If someone's interested, you could just have them. Basically, these long rectangles represent x's, and each tiny square represents 1, like 1 penny, 1 block, 1. It's just the number 1. So if I wanted to know which of these algebra tiles seems like it would correctly represent this equation, and the equation says 5x is equal to 25. So we would be looking for 5 of these x rectangles. Well, this only has 2 x rectangles, so nope, that only has 2 x rectangles, so nope. And then we want 25 ones. So this bottom one does not look like it has enough. So then this would be the correct representation. Doesn't show us how to solve it yet, just getting us used to how would we even model that equation to help us, to help the equation not seem so abstract to us, but to seem like something that's concrete that we could really manipulate and get our hands on and our minds around. It apparently doesn't think I've answered the question because I didn't actually click it, I just circled it. So this time it says negative x plus 5 is 11. So the negative x, notice they're using a pink x instead, and it even says right on it, negative x. A positive 5, so we don't have any reason to use those negative ones, and then equals 11. So the only one that even looks like negative x plus 5 appears to be this bottom one. And then I would want to count, is the rest of this also look like it works? Yes, it does. So this time we have to choose which one of the equations this represents. So I would count my x's, 1, 2, 3, 4, 5. So it looks like 5x. There are 5 ones. And then my equal sign. And then 1, 2, 3, 3 times 3 is 9, plus the extra one is equal to 10. So 5x plus 5 is equal to 10 would be our solution, or our equation. Sorry about that. So at that point, those kind of questions at the beginning of that lesson are just giving us choices, right? We didn't have to type anything in, come up with it ourselves. We just had to choose. And we were not solving yet. So here I'm still not solving, but now I don't have choices. So this would be, we've got 2 of the x's, and there's positive 1, 2, 3, 4, so plus 4, then the equal sign, and then I see there are 1, 2, there's 3, 6, 9, 12, 15, and one more makes 16. So that equation is 2x plus 4 is equal to 16. So far so good, I hope. So now we're looking at solving. So with algebra tiles, when we're solving, we want to try to get that x tile by itself. Okay, so we're trying to get that x tile by itself. So to counteract the positive ones, we could add negative ones to those, because a negative and a positive would cancel each other out. Or I could think of it as I'm taking away 1 on each side. So let me make this a little bit bigger because it's a little small there. Some of you might be saying, it's about time you did that. So here's a 1. Let's see, there's 1. Oops, turn my pencil on. There's 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So I would be getting rid of 7 ones. So I would also get rid of 7 ones on the other side. Then my x would be by itself, and it's equal to 1, 2, 3, 4, 5, 6, 7. So it is 7. I'm going to put the wrong answer because I want to see how they explain this, because I think they're going to use negative ones instead of crossing things out. So it is 7, like I said, but didn't answer. No, they actually said the same thing as I did. Remove 7 1 tiles from each side. So if we look back in our notes, that's very much like what I'm going to tell you next in your notes, that when you solve things, we're going to use what are known as inverse operations. So that was an addition equation. It said x plus 7 is equal to 14. And to solve it, we used subtraction. So to undo this plus 7, we do minus 7. And whatever we do to one side, we must do to the other side. This is our golden rule of algebra, that whatever you do to one side of the equation, you must do to the other side. That makes that 7 0 pair out, and we know that anything plus 0 is just itself. So now x is by itself, and then 14 minus 7 is 7. So if it starts out with an addition equation, if something is being added to the variable, then we're going to subtract to solve. If it's a subtraction equation, the opposite of subtraction, you got it, addition. So if it starts out with subtraction, then to solve, we're going to have to add 5. Now, please know that there are going to be times you might see an equation that looks like this. Nope, that's not what I wanted. We're going to have equations, for instance, that maybe say 5 minus x is equal to 7. This is really a two-step equation, and I see that there is subtraction, but you're trying to get the x by itself, so we really want to get rid of that 5, and so since the 5 is positive, we would subtract 5, because adding 5 is going to make that a 10. If we were going to add something, we'd be adding x, and then that would move the x to the other side, and then we would subtract the 7. Or we can subtract the 5. That negative sign is stuck to that x, and then this would mean that the opposite of x is equal to 2. So that's like saying negative 1x is 2. So if we divide by negative 2, or negative 1, we get negative 2. I'm jumping ahead of myself. So that one's a little bit of a tricky one, just kind of to prepare you that that's going to come up. But just think, you want to get rid of the constant that's on the side with the x. A constant is a term that's not being multiplied by an x. So our other two one-step equations would be a multiplication equation. So for instance, negative 5 negative 5x is equal to 40. So now that doesn't mean negative 5 plus x. So I won't be getting rid of that by adding 5. This means negative 5 times x, since they're right next to each other. So when it's beside it, you're going to need to divide it. So we solve multiplication equations by using division. So I'm going to divide by whatever that coefficient, the number multiplied times the x is called the coefficient. Divide both sides by the coefficient. And then we know when we divide opposite signs, we get a negative. Any equation, I should always be able to plug my answer in and get a true statement. So negative 5 times negative 8 should equal 40. 5 times 8 is 40. Same signs, answer is positive. So it checks. It works. So when I say check your work, I don't mean look at it 4 times. I mean take your solution, your value for x or whatever variable, and replace the x with that number and make sure both sides of the equation are indeed equal. And then division equations, you might guess, will be solved with multiplication. So multiplication and division are inverse operations. And division equations are typically written as a fraction, like n over 3 is equal to 10. So we're saying some number divided by 3 is equal to 10. I tend to use x a lot, but there's nothing magical about that. Your variable could be any letter. So to get rid of this 3, to undo the division, I need to multiply. And whatever I do to one side of the equation, I have to do to the other. On the left side, the 3 that you're multiplying by just gets rid of this 3. Because remember, 3 over 3 is 1. 3 divided by 3 is just 1. So this is now just 1n. And then 10 times 3 is 30. So in IXL J3 is about equation solving. It's all one-step equations. You may use a calculator. I would encourage you to, so don't be freaked out by seeing a decimal because you're allowed to use a calculator, but you still have to know what operation do I need to use to solve this. For these ones that are just one step, you might not find it's necessary to write it down. But once we get into 2-step and longer, I would encourage you, especially if you're new at it, to write it down. Just because your problems are on the computer doesn't mean that writing things down wouldn't be helpful. If you're in class, you're welcome to use a dry erase board. If you need some paper, I have paper for you to write things down. So if it says 2t, that means 2 times t. So we're going to divide to solve. Notice I also made my t capital just because otherwise it kind of looks like a plus sign for me. So then 8.8 divided by 2, t would equal 4.4. So when you divide, top divide it by bottom. Sometimes the answer, the bottom number might be bigger. So sometimes we'll leave the answer in a fraction. Sometimes it could be a decimal that does not have a whole number part. So always top divide it by bottom. So notice they're going to mix it up with the variables. This one says solve for m, and it is starting out as a division problem. So remember, fractions indicate division. Notice also the m this time is on the right. That's okay, doesn't matter. We're still trying to get it by itself. So we want to get rid of this 3 that's in the denominator. So to get rid of it, since it indicates division, I'm going to multiply. And whatever I do to one side of the equation, I have to do to the other. So then 3 times 3 . So 9 is equal to m. That's the same thing as m is equal to 9. So this one is addition. If the iPad catches up, there we go. b plus 3 is equal to 9.7. So to solve, we would subtract 3 on both sides. And in IXL, if you miss one, you're going to see that they write it out like this. And that was actually the way I was taught when I was in school. But it is so much less writing. And I think for most of my students, so much more obvious. If this is my starting equation, if I just write minus 3 minus 3. It's the same thing, right? This is the new part. But it's just much more obvious that I've done the same thing on both sides. And it's less writing. And every time you write something, that's a chance to write something incorrectly, like copy it wrong. So, and remember the 3 as a whole number would be under the 9, not under the 7. And also you could use a calculator, but so 6.7. So those are some one-step equations. So that's what you should do for J3. And I'll make another short video, be a little bit shorter for two-step equations.